Welcome to Learn Commerce PU online classes. Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to our first PU Computer Science online classes. In last class, we completed the second chapter. The second chapter name Input Output Memory Devices. And we know that some important topic, that is our primary memory, some types of the primary memory, secondary memory, and also some of the types like floppy disk, hard disk, or maybe PSD, portable storage disk, and also last thing about our cache memory. Now in today's class I selected the new chapter. The name of the chapter is the problem solving technique. Now we are in the chapter, it is a new chapter. The name of the chapter is the problem solving technique and the chapter 5. Now what about our problem solving technique? So whatever is there in our first PU syllabus, everything going to start from this chapter only. Now still whatever we learned, maybe input output, it's a general knowledge about this one. Everyone knows about this one, correct? No? Now whatever is that, we are going to start from this chapter only, our first PU syllabus here. So we can say that about the first thing about the problem solving technique. So first thing I want to start from the definition. So what about the definition? So we can say that the problem solving technique can be defined as the task of expressing the solution of complex problems in terms of simple operations understood by the computer. That means here the meaning is very simple. Maybe the problem is very complex. Maybe, or we can say as the problematic. We can't solve such problems here. So how we are going to solve such problem? By using some of the simple operation we are going to apply to the problem, and in this manner we are going to solve the problems here. So this is the meaning of the definition of problem solving technique. So clear this point here. So we can say that the task of expressing the solution of complex problems, that means maybe if any complex problem is there, problematic problem is there, so such problem we are going to solve by using some of the simple operation, by applying some of the simple operations, and such operation should be understood by the computer. Why? Because here we are not going to solve by using the book and each and everything. Whatever the problem is there, we are going to solve just by using the computer. So what's the problem we are going to solve by using simple method? Such method should be understood by the computer here. So this is about the definition of problem solving. Okay. Now after the definition of the problem solving, now we are going for our next concept, that is the different stages are. The different stages of the problem solving technique. So there are totally 7 stages are there. So in our problem solving technique, while going to solve some of the problems, we need to follow all those stages, all those steps here. So totally in our problem solving technique, there are 7 stages or the 7 steps are there. So the first stage or the first step is the problem definition. The second one is the problem analysis here, and the third one is the design of a solution by using tools such as flowchart and the algorithm. Okay, but in this class, or maybe whatever you are going to see on the board here, just I added 3 points only. Why? Because after that I want to tell some other thing about our top down design and stepwise refinement. It is not the stages of the problem solving technique. Now just I already said there are totally 7 stages are there. First one is the problem definition. Second one is the problem analysis here. Third one is the design of a solution using the tools such as flowchart and the algorithm. The fourth point is the programming the computer, that is called as the coding. Clear this point here? Programming the computer, that is called as the coding. And later fifth one is the checking and correcting the errors. So here checking is called as the testing, and however they are correcting the errors is called as the debugging. Clear this point here? And the sixth point we can say as the program documentation, and such program documentation only called as the documentation of the program. That means here we are going to write some of the comment line. Okay, what's the use or what's the information about this statement, each and everything. So this is called as the program documentation. And the last stage we can say as the program enhancement or the program maintenance. Clear this point here? So totally 7 stages are there. Clear now this point about how many stages are there in our problem solving technique. So lastly, just last time I want to repeat the stages. So the first one is the problem definition, second one is the problem analysis, third one is the design of a solution using some of the tools like flowchart and algorithm. Okay, next one is the coding, that is called as the programming the computer. Next thing about our checking and correcting the errors. So the checking called as the testing and correcting errors called as the debugging here. Okay, and later sixth one is the documentation of the program, that is called as the program documentation, and the last stage is the program maintenance or the program enhancement. Okay, now 7 stages are over. Now let's, in this class I am going to explain the each stage one after the another. Why? Because I already repeated many times. Correct? No? What are the stages? It's a very important question for the 5 marks here. So now I am going to start the explanation from each stage in this case here. So first of all I am selecting the problem definition. Okay. Now we are in the concept. The concept is the problem definition. So we know that totally there are 7 stages are there. So first only I am going to start the word, that is, so this is the first stage in computer problem solving. Correct? No? Everything or whatever the problem is that we are going to solve by using computer. So we can say the problem definition is the first stage, first step in computer problem solving. So what are the things we need to know in our problem definition when you are going to solve any problems? So the first thing we can say, or the first point, the problem is clearly understood by the user, understood by the programmer. Is it? First of all, maybe going to take any problem or maybe whatever the given problem. First of all, we need to understood it properly. So this is, if you don't know what's the problem, is it able to solve the problem? No, we can't solve the problem if you don't know what's the problem. So the first point, whatever the problem is that, first of all, such a problem should be understood by the programmer. Clear this point here? And the second point we can say that the problem solver. So who is called as the problem solver? The problem solver means who are going to solve the problem is called as the problem solver. So the problem solver must understand the problem thoroughly in terms of the requirement. That means while going to solve the problem, maybe the problem I want to add 2 numbers. So that means sure we need to take 2 numbers. Just by using 1 number, is it possible to add the number? No. So this is the requirement. The requirement is when you are going to add numbers, when you are going to make the addition by using 2 numbers, that means we should need to take 2 numbers only. Clear this point? So this is the requirement. So like that only, first of all, the problem solver must understand the problem thoroughly in terms of the requirement. The requirement means what are the input and output operations are to be performed. Maybe while going to solve any problem, we should know what are the input we need to take while going to solve the problem, and after taking the input, it going to display the correct output operation. Clear this point here? So it depends on the inputting of the value. If whatever the inputting, if you are not going to take properly, we can't get the desired result. Is it here? So we can say that the first point we know that clearly understood it, what's the problem here, and second thing, we need to use a proper requirement about the input and the output operations here. And laterwards we can say that the problem definition. So whatever the problem is that should be right in user's language. Clear this point here? We should know. So whatever the problem, if anyone or maybe if you are going to write, you should write it properly and should be in our user's language. That means maybe the user's language such as the English language or maybe any natural language, which language you are going to understood properly, maybe you have to use any one language here. So we can say that the problem definition should be in the user's language here, the language like maybe the English or maybe your that means maybe your understandable language in this case, or maybe while going to write any problem or each and everything, if you are using the table or the chart, then sure it very clearly all those problems should be clearly understood by the user. So that means we can say that it may also include some of the chart or the graph just to understand it here. And finally, just in our problem definition, I want to tell, if the problem is not understood properly, we don't know, we have the problem, okay, they already given the problem, we have the problem here, but also we don't know what's the problem, how to solve the problem. That means if the problem is not understood properly, then we will not get the desired result. So clear this point here? Artha aita ellarige? What about, so if you don't know ಯಾವುದೇ ಒಂದು ಪ್ರಾಬ್ಲಮ್, ಆ ಪ್ರಾಬ್ಲಮಿನ ಬಗ್ಗೆ ಅದಕ್ಕೆ ಹೇಗೆ ಇನ್ಪುಟ್ ತಗೊಳ್ಬೇಕು, ಹೇಗೆ ಔಟ್ಪುಟ್ ಡಿಸ್ಪ್ಲೇ ಆಗ್ತದೆ, ಆ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡಬಹುದು, ಸೊ ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿಥಿಂಗ್ ನಿಮಗೆ ಗೊತ್ತಿಲ್ಲ ಅಂತ ಹೇಳಿದರೆ ಇಟ್ ನಾಟ್ ಪಾಸಿಬಲ್ ಟು ಗೆಟ್ ದಿ ಕರೆಕ್ಟ್ ರಿಸಲ್ಟ್. ಸೊ ದಿ ಕರೆಕ್ಟ್ ರಿಸಲ್ಟ್ ಓನ್ಲಿ ಐ ಯೂಸ್ಡ್ ಆಸ್ ದಿ desired result here. So clear this point here? So this is about our first thing in our problem while going to solve any problems here. So clear now to everyone about the problem definition? So we can say that just only the first thing we should know how, what's the problem, and second thing we should know how to solve the problems here. That means while going to solve, what are the input and output operation we need to follow in this case, and what's the problem is that such problem should be right by using some of our natural languages, that is called as the English language. And if you include any chart, graph, each and everything, then no problem, the each whatever the problem is that it going to understood by the user here. And if the problem is not understood properly, then not possible to get the correct result. Okay, now after the problem definition, later next one is about our problem analysis. Okay, now problem analysis ಹಾಗಾದ್ರೆ ನೋಡುವ ಈ problem analysis ಅಲ್ಲಿ ಏನೆಲ್ಲ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Okay, now the given problem, already ನಮಗೆ ಒಂದು problem ಸಿಕ್ಕಿದೆ. So the given problem must be solved, or the given problem here we can say that must be solved in this case here, or must be understood or analyzed it before going to solve any problem. Clear this point here? So ಯಾವುದೇ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಸಿಕ್ಕಿದ ಕೂಡಲೇ ಸ್ಟಾರ್ಟ್ ಮಾಡೋದಲ್ಲ ಆ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ. ಮೊದಲು ನೀವು ಏನು ಮಾಡ್ತೀರಿ, ಆ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡಬಹುದು ಅದರ ಬಗ್ಗೆ ಕೆಲವೊಂದು ನೀವು ಪಾಯಿಂಟ್ಸ್ ಅನ್ನು ಕಲೆಕ್ಟ್ ಮಾಡ್ತೀರಿ. ಕರೆಕ್ಟ್ ನೋ ಇನ್ ದಿಸ್ ಕೇಸ್ ಯಾ? ಸೊ ಆ ಎಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ನಮ್ಮ ಅನಾಲಿಸಿಸ್ ಅಲ್ಲಿ ಬರ್ತದೆ. ಕ್ಲಿಯರ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಯಾ? ಸೊ ವಿ ಕ್ಯಾನ್ ಸೇ ದಟ್ ದಿ ಗಿವನ್ ಪ್ರಾಬ್ಲಮ್ ಮಸ್ಟ್ ಬಿ ಅಂಡರ್ಸ್ಟುಡ್ or analyzed before going to solve any problems here. Okay, so this problem or the problem analysis determines the data items and the relationship. So clear this point here? So ನಮಗೆ ಗೊತ್ತಿದೆ ಆ ಪ್ರಾಬ್ಲಮ್ ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡೋದಂತ. ಸೊ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಯಾವುದೇ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡುವ ಮುಂಚೆ ಆ ಪ್ರಾಬ್ಲಮಿನ ಬಗ್ಗೆ ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡಬಹುದಂತ ನಾವು ಪಾಯಿಂಟ್ಸ್ ಅನ್ನು ಕಲೆಕ್ಟ್ ಮಾಡ್ತೇವೆ. ಸೊ ವಾಟ್ ಆರ್ ದಿ ಪಾಯಿಂಟ್ಸ್ ವಿ ನೀಡ್ ಟು ಕಲೆಕ್ಟ್ while going to solve the problem? So the first problem or the problem analysis, in this case we can say that this determines the data items and the relationship. Data items ಅಂತ ಹೇಳಿದ್ರೆ ಈಗ ನನಗೆ ಯಾವುದೇ ಒಂದು ನಂಬರ್ಸ್ ಆಡ್ ಮಾಡಲಿಕ್ಕೆ ಇದೆ. ಮೇ ಬಿ ದಿ ನಂಬರ್ಸ್ ಆರ್ 5 plus 5. Okay kya? So we know that the 5 and 5, the numbers 5 and 5 I want to add. So this is called as the data items. Clear this point here? Now this is called as the data items. In this case I need to use in the program while going to solve the problem here. Maybe the problem is add the sum of the numbers here. Clear this point here? Add or the addition of two number, it is the problem. So while going to solve the problem addition of two number, then sure I am going to collect two numbers. Maybe the numbers are 5 and also the 5 here. Clear this point? So this 5 and 5 called as the data items. And later also we can say that about the relationship in this case here. So what are the relationship? The relationship is addition of the two numbers. So that means I am going to make the relationship in between the numbers here. So this is called the data items. We need to collect properly the data item, and also we know to use the relationship between the data items here. Clear this point here? And also we can say that the user must understood or must specify the operations. The operation may be the logic operation, in logic operation, and operation, or operation, not operation, or maybe the arithmetic operation. So in this example I use the arithmetic operation. The arithmetic operations are addition, subtraction, multiplication and the division. So clear this point here? So ಯಾವಾಗ ನೀವು ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ ಹೋಗ್ತೀರಿ ಆಗ ನಿಮ್ಮ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಏನು, ಫಸ್ಟ್ ಆಫ್ ಆಲ್ we need to determine the data items. Clear this point here? And also we need to know the relationship between the data items, how to create the relationship from one variable or from one data item to the another data item here. And also the user who are going to solve the problem is called as the user or the problem solver here. So the user should specify the operation. The operations are maybe the arithmetic, addition, subtraction, multiplication, division, or maybe the logical operation. Any one operation you are going to use, you are going to perform while solving the problems here. And lastly we can say that in problem analysis, okay, the programmer try to understand the requirement of the problem to be solved. So some of the requirement while going to solve the problem are input and output requirement. Before without going to take input, is it able to get the output? No, it's not possible to get the output. First of all we should know the correct input. What are the input we need to take while going to solve the problems in this case here? Clear this point? So first one is the input here and also the output requirement. If you are getting correct input, there is no doubt you can give the correct result in this case. And not just only the requirement about input and the output, some other requirement are processing requirement. So the processing, we know that the processing is only called as the CPU. Clear this point here? The processing called as the CPU, and here we are going to solve the problem by using the computer here. So first of all, whatever the maybe any computer, so what's the computer we are going to use here? Such computer should work properly. That is called as, that means whatever the computer is going to work just because of the processor. So second thing is the processor requirement. Correctly you have to use the processing or the processor requirement here. And the third point we can say about the time constant. Maybe if you are taking any problem and you are going to solve this problem, maybe after 1 month, 2 months, it's not called as the correct we are going to solve, correct? No, whatever the problem is there, such problem should be solved in our correct time, that is called as the time constant. Clear this point here? And also the memory limitation. Maybe our computer memory is full and you are going to solve the problem. Is it correct here? No. Why? Because whatever the problem is there, or what's the problem we are going to solve by using computer, first of all we should know whether the memory space is there or not in our computer in this case. And also we can say that in our requirement, not just only the input and output requirement, we need to know, or we need to correct in this case here, also the time constant requirement, and also our processing requirement here, and also we can say that the memory limitation requirement, and finally the error handling etc. are going to understood at this stage. So clear this point here. So this is about our problem analysis. Arthaita in our problem analysis here. So first of all problem analysis ಅಲ್ಲಿ ಯಾವುದೆಲ್ಲ ಡಾಟಾ ಐಟಮ್ ತಗೊಳ್ತೇವೆ, ಆ ಡಾಟಾ ಐಟಮ್ ಇನ ರಿಲೇಶನ್ಶಿಪ್ ಏನು, ಅದರೊಟ್ಟಿಗೆ ದಿ ಯೂಸರ್ should specify some of the operations like addition, subtraction, multiplication. What are the operations they want to use while going to solve the problems here. ಅದರೊಟ್ಟಿಗೆ ಕೆಲವೊಂದು ರಿಕ್ವೈರ್ಮೆಂಟ್ ನಮಗೆ ನೋಡ್ಕೊಳ್ಬೇಕಾಗ್ತದೆ. ಸೊ some of the requirement are input and output requirement, time constant requirement, and the processor requirement here, and also the memory limitation requirement. Each and everything we need to understood in our problem analysis stage. Clear this point here? Okay. Now after completing the problem analysis, the design of a solution tool such as, or by using the tool such as the flowchart and the algorithm. Now the second two stages we already completed, that is from our problem solving technique here. Now I am in the third point. The third point is the design of a solution using the tools such as flowchart and the algorithm. So now we know what are the input, output, each and everything we already collected while how to solve the problem. So each and whatever the information we need, we already collected by using the stages like our the problem definition, and also with this stage like our problem analysis. Now what's the problem, or whatever the data item we collected, we are going to use in our third step. Okay. So this step answer all the questions how during the problem solving. So whatever the answer we will get in this stage only here. Why? Because what we want to collect, we already collected in first and second stage. Each and every point we already noted in our first and second stage here. Now whatever the answer we will get, such answer will get in our third stage. So this step answer or provide answer all the question, for all the questions. This step provide answer for all the questions in this case here. So what get the answer, or while to get the answer, what are the technique we need to use? So here some of the technical tools we need to use. The technical tools are the flowchart and the algorithm. Clear this point here? So here to get the answer, we are using some of the design tools, technical tools here, the tool such as the flowchart and the algorithm. Now I am not going to tell anything about our flowchart and algorithm. Let's see later words. But before going to tell the flowchart and algorithm here, first I want to complete the most important question, top-down design. So everything going to start from this point only, the all problems, each and everything. So the top-down design. What do you mean by a top-down design? The meaning, the approach of dividing a problem into sub-problem. Now this is one problem, okay? It is one problem, single problem here. Now how I am going to complete the problem? How I am going to get the answer of the problem? So I am using this step. I am using the process or the approach. The approach is dividing a problem into sub-problems. So I divided such problem into 4 parts. Clear this point here? ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಹೇಗಿತ್ತು, ಒಂದು ಲೆಂತಿ ಪ್ರೋಗ್ರಾಮ್ ಆಗಿತ್ತು. ಆದರೆ ನಾನು ಟಾಪ್ ಡೌನ್ ಡಿಸೈನಿನ ಅಪ್ರೋಚ್ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾನು ಏನು ಮಾಡಿದ್ದೇನೆ, ನಾನು ಈಗ ಆ ಲೆಂತಿ ಪ್ರೋಗ್ರಾಮನ್ನು ನಾನು ಜಸ್ಟ್ 4 ಯೂನಿಟ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡಿದ್ದೇನೆ. ಸೊ ಡಿವೈಡಿಂಗ್ ಎ ಪ್ರಾಬ್ಲಮ್ ಇಂಟು sub problems, clear this point here, and then dividing the sub problems further until, first of all just 1 ಯೂನಿಟ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡಿಕೊಂಡಿದೆ. ಆದರೆ ನಾನೀಗ ಏನು ಮಾಡಿದ್ದೇನೆ, ಆ 1 ಯೂನಿಟ್ ಅನ್ನು ಪುನಃ 2 ಡಿವೈಡ್ ಆಗಿ ಮಾಡಿಕೊಂಡಿದ್ದೇನೆ. ಕ್ಲಿಯರ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಹಿಯರ್. ಸೊ ದೆನ್ ಡಿವೈಡಿಂಗ್ ದಿ ಸಬ್ ಪ್ರಾಬ್ಲಮ್ಸ್ further until, clear this point here. Again I am going to divide each and every point, each and every unit module, clear this point, just to get the computer solution, just to get the correct result or the desired output here. So this is called as the top down design. So in this manner we are going to solve the problems. So clear this point here. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ? ನಾವು ಯಾವುದೇ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಡೈರೆಕ್ಟ್ಲಿ ಆಗಿ ಆ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಸಾಲ್ವ್ ಹೋಗುದಿಲ್ಲ. ನಾವು ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡ್ತೇವೆ, ಆ ಇದ್ದ ಒಂದು ಲೆಂತಿ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಡಿವೈಡ್ ಮಾಡಿದ ನಂತರ ಆ ಡಿವೈಡ್ ಅಲ್ಲಿ ಕೂಡ ನಾವು ಸಬ್ ಡಿವೈಡ್ ಮಾಡಿಕೊಂಡು ಅಂತ ಪ್ರೀತಿಯಲ್ಲಿ ನಾವು ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ತುಂಬಾ ಈಸಿ ವೇಯಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗ್ತೇವೆ. ಕ್ಲಿಯರ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಹಿಯರ್. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದಿ ಟಾಪ್ ಡೌನ್ ಡಿಸೈನ್. ಕ್ಲಿಯರ್. ಸೊ ದಿ ಅಪ್ರೋಚ್ ಆಫ್ ಡಿವೈಡಿಂಗ್ ಎ ಪ್ರಾಬ್ಲಮ್ ಇಂಟು sub problems, then dividing the sub problems further until for the solution of the computer to get the correct result here. Clear? And now this unit is called as the unit module segment. So ಈ ಯೂನಿಟ್ ಅನ್ನು ಏನಂತ ಹೇಳ್ತೇವೆ, ಸೊ ನಾನು ಡಿವೈಡ್ ಮಾಡಿದ ಪಾರ್ಟ್ ಇಲ್ಲಿ ಕೆಲವೊಂದು ಡಿವೈಡ್ ಮಾಡಿದ್ದೇನೆ. ಸೊ 1 2 3 4 5 6 7. Clear this point? If you want, you can divide this one also. Now it is a 8. So each part, clear this one, the divided part is called as the unit, module or the segment. Okay? Here, so like that we are going to use the name of the division part here. Now, okay, we know that the meaning of the top down design. Now let's this stepwise refinement. So what do you mean by a stepwise refinement? There is no any extra point, there is no any other answer for this stepwise refinement. So whatever the meaning I set in our top down design, the same meaning we can say for our stepwise refinement here. So the meaning of stepwise refinement, the process of here breaking down the problems, that means here how I break the problems in this case here. So one by one here. So I stop the problem. Correct now here. So the process of breaking down the problem at each stage. Clear this point here. The process of breaking down the problem at each stage to obtain a solution. Why we are going to stop the problem just to get the desired result, just to get the correct output here. So in this manner we can get the correct output. Just only we are going to stop the problem in this case in correct way, in correct manner, in correct site here. So this is called as the stepwise refinement. So clear now about our top down design. So this method also we are going to use while going to solve the problem, and also we are using this process stepwise refinement. That means the process of breaking down the problem at each stage. Why we doing this type of method here or this type of process, just to get the correct answer. Clear? Okay. Now in last class we know that some important concept, that is from problem solving technique, and in this concept first I started from the definition, later I completed some of the stages like problem definition, problem analysis, design of a solution using design tool like algorithm and flowchart. Then I selected the concept top down design and also the stepwise refinement. So the top down design, we know that the meaning of the top down design. So the top down design is the process of dividing a problem into sub problems, then dividing sub problems further until. So maybe one lengthy program going to divide is called as the top down design, and after dividing again such division going to divide into subdivision, and like that we are going to solve the problems. Now let's one example, suitable example for our top down design. Maybe if any problem is there, how we are going to solve this problem, how we are going to divide the problem, and again the dividable problem again we are going to subdivide. So in this example it will be clear to everyone about our top down design. So the question or the example. Question is problem, it is one problem. The problem is the to find area of a triangle. Okay. So this is the problem, to find the area of a triangle. So we know that to find, or when you are going to find out the problem area of a triangle, we need to divide such problem into 3 sub problems. Correct? No? We need to divide into 3 sub problems. So first one is the input data. Without taking input data, we can't get the output. And after taking the data, inputted data, by using such a data, I am going to make the calculation that is called as the compute data. So first of all, I am taking input data. Okay. One problem going to divide into 3 sub problems. So first of all, I am going to take the input data. What are the data I need to use while going to solve the problem? And what's the data I needed or I inputted to solve the problems? Then by using such a data, I am going to make some of the calculation that is called as the compute data here. And lastly, after the calculation of such data, later was after the calculation will get the desired result that is called as the output data. Clear this point here? ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ? ನಾನೀಗ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ ಹೋಗ್ತಾ ಇದ್ದೇನೆ. ನೇಮ್ ಆಫ್ ದಿ ಪ್ರಾಬ್ಲಮ್ ದಟ್ ಈಸ್ ಟು ಫೈಂಡ್ ದಿ ಏರಿಯಾ ಆಫ್ ಎ ಟ್ರಯಾಂಗಲ್. ಸೊ ಯಾವುದೇ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಇರಲಿ, ಆದ್ರೆ ನಮಗೆ ಈಗ ಒಂದು ಗೊತ್ತಿದೆ ನಾವು ಯಾವ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡಿದ್ದೇವೆ. ಸೊ ಆ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ನಾನು ಸೆಲೆಕ್ಟ್ ಮಾಡುವ ಮುಂಚೆ ಸೊ ನಾನು ಏನ್ ಪಾಯಿಂಟ್ ನೋಟ್ ಮಾಡ್ಕೊಳ್ತೇನೆ, ಅದರಲ್ಲಿ ಆ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ನಾನು 3 ಡಿವೈಡ್ ಆಗಿ ಆ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು 3 ಓಕೆ ಡಿವೈಡ್ ಮಾಡಿ ಬಿಡ್ತೇನೆ 3 ಟೈಪ್ಸ್ ಆಗಿ. ಸೊ ಇನ್ ದಿಸ್ ಕೇಸ್ ಸೊ ದಿ ಫಸ್ಟ್ ಒನ್ ಇಸ್ ದಿ ಇನ್ಪುಟ್ ಡಾಟಾ. ನಮಗೆ ಯಾವುದೆಲ್ಲ ಇನ್ಪುಟ್ ಬೇಕು ಆ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ ಆ ಬಂದ ಇನ್ಪುಟ್ ಅನ್ನು ನಾನು ಮತ್ತೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಬಿಡ್ತೇನೆ. ಆಫ್ಟರ್ ದಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ವಿ ವಿಲ್ ಗೆಟ್ ದಿ ಔಟ್ಪುಟ್. ಓಕೆ. ನಾ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ದಿ ಏರಿಯಾ ಆಫ್ ಎ ಟ್ರಯಾಂಗಲ್ and later I divided into 3 sub problems are input data, compute area, that is our compute data, compute area. Okay. Now output data, that is the output area, we can say that. So otherwise we can write input area, compute area, output area, there is no any problem. Okay. Now this problem is that we know that going to divide into 3 sub problems. Now again such sub problems are going to divide further until, clear this point here, further again I am going to divide. So how I am going to divide? The division going to do as the input base. We know that just to solve the problem area of a triangle we need base as well as the height, and we need we know the formula also. The formula is the area is equal to half into base into height. So this is the formula. So first of all we know that just to know the answer of the area of triangle we need to use in our input, the inputting values are the base as well as the height. So I divided such input data into subdivision as the base as well as the height. Clear this point here? And later after knowing the input, base and height, I am going to do the calculation. So area is equal to half into base into height, and after the calculation I will get some of the output result. Correct? No? Otherwise simply we can say as the result here. So the result of the area of triangle here, otherwise simply we can write as the output height and the output base in this case here. So clear this point here, the output height or the output base in this case here, otherwise simply totally we can write as the output area. So clear, so both is called as the result of the area of a triangle here. So clear now about this program, each and everything, and we know what's the problem and what's the question of the problem and how we are going to divide or how we are going to get such problem answer here. Now after completing the example, one suitable example for our area of a triangle, now let's the next thing about our advantage of the top down design, the advantages of top down design here. So what are the advantages is that, so we can say that we know the method, the process, what's the method we are using, we already know, and completed by using one example, one problem going to divide into sub problems here, then such a sub problem going to divide further until, correct no? So when you are going to do the process, such problem or whatever the problem is there are very easily understood. So this is the first point in our advantages. In this manner we are going to get the answer, or in this process we are going to do in our top down design here, one problem going to divide and such problem going to divide again and again here. So we can say that whatever the method we are using in our top down design, so all those method it possible to get, or the problem are very easily we can understood how to solve the problems in this case here. And also we can say that the problem are logically organized also. Clear this point here? Not just only we can easily understood what's the problem, and also we can say that here the problem, that means whatever the logic we are going to use in the problem here are logically organized, all those logic in this case here. And also we can say thus there is a structure to the solution of the problem in this manner. First of all we should know, or the problem are very easily understood, and also we can say that here some of the logical method we are going to use in the problem while going to solve the problem. So all those method very easily we can understood in this case here. And later next one is about our second point. Maybe if you want to make some of the changes in the problem, that is called as the modifications. Okay, yeah, maybe I want to do some of the changes while going to solve the problem, or maybe while solving the problem here. So that is called as the modification, that means in simple words called as the changes. So the modification or changes can be easily made to the module. We know the meaning of the module, correct no? One lengthy problem divide into part. Now this is also called as the module. If you are going to divide again, now this is also called as the module. So clear this point here. The each part, each unit is called as the segment, module or unit of the program here, or the problem in this case here. So the modification or changes can be easily made to our module. If you want to make some of the changes, very easily we can do here. And later next one, the third point we can say about the testing the solution can be easily performed. Okay, maybe we know the meaning of the testing. What do you mean by a test here? Maybe after completing the program, if you want to check the program here, then we are going to make the checking of the program. In this case we are going to test the program whether every line, whether every word is proper or not, is it able to get the desired result here. So just only we need to make some of the testing in the program, that is called as the testing. The testing only called as the checking of the program. Clear this point here? So the checking of the program can be easily performed by using, so all are called as the advantage of the top down design here. So clear this point. So the first advantage, that means by using the method like our top down design, whatever the problem are there, such problem very easily we can understood here. And also while going to solve the problem, we using some of the logic method, correct? No, here the logic method is one problem going to divide into part, again going to divide into subdivision. So all those are the logic. We are using some of the logic here while going to solve the problems here. So thus there is structure to the solution of the problems. Okay, so in this manner we are going to solve the problem. We are getting the solution of the problems in this case. And later next one is the second point, we can say as the modification. Modification ಅಂತ ಹೇಳಿದ್ರೆ ಏನೋ ಒಂದು ಚೇಂಜಸ್ ಮಾಡಲಿಕ್ಕೆ ಇದ್ರೆ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ನೀವು ಬರೆದ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಅದನ್ನು ನಾವು modification ಅಂತ ಹೇಳ್ತೇವೆ. ಸೊ ಆ modification ಪಾಯಿಂಟ್ ಅನ್ನು ಕೂಡ ನೀವು very easily you can do it in our top down design here. Clear this point. So modification of changes can be easily performed, and also testing the solution can also easily perform. So all are called as the advantage of the top down design. Thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.